Good morning to all. Today we are going to discuss about the stack concept under the programming data structures topics. So basic idea which is beginning the stack is it is an abstract data type commonly used in most programming languages. It is named stack as it is behaved like a real world stack. For example, deck of cards or pile of plates we can arrange in a one by one like a stack. Stack can be represented with the help of this that following diagram. So here it can be implemented by means of this two different type of this data structures. One is the array, another one is the structures as well as the pointer and then linked list. So first we will be seeing how we are going to implement the stack using this array, followed by these structures and then pointers and then linked list concept. Stack can be either a fixed or dynamic size. So we can able to perform this that two different type of these operations in a stack. One is the push operation, another one is the pop operation. So it can be worked with the logic of this lost in first out concept. So LIFO, LIFO concept. So which means that the element which is insert the at the top of the stack can be removed from the stack. So insertion and then deletion can be happening at this one end, which is nothing but this push and then pop operation can be happening in this only one side. So these are the operations we can able to perform on the stack. We can able to push the element into the stack and then pop the element. Push is nothing but the inserting the element into the stack. Pop is nothing but this the deletion of this element from the stacks. We can able to create the stack and then we can check whether the stack is empty or not, and then we can also perform whether it is full or not. These are the basic operations we can able to perform on the stack operations. So as I said, stack can be work under the principles of this lost in first out concept. So these are the function we can able to use inside the C programming to perform this that inserting the element into the stack. So for that I am going to use this that push functions. So here the stack followed by this that pointers star s and then what element we are going to push into the stack. As well as the next we are going to perform the pop operation with the help of this syntax. So int followed by this that pop operation name, and then here also I am going to use the pointers variable to remove the element and return the element from the top of the stack. As well as we can able to create the stack. Before going to create the stack, we have to check whether the stack is empty or not. So for that we are going to use the create function. As well as we can able to check whether the stack is empty or not before going to perform this any kind of operations under the stack. As well as we have to check whether it is a stack is full or not. These are the basic operations we have to perform by using this stack concept. First we will be see stack operation using this array. So as I said, first one is the push operation. You can see I am going to represent array like this. So the pointer initially is pointing to the top of the stack. When I am going to perform this that push operation, it happened at the top of this array. So this is nothing but this pushing the element into the stack. Then if you want to perform this that pop operation the same using same in the same stack, so whichever the element is recently inserted here now that has to be removed from the stack. So as I said that both operation push and then pop operation can be performed at the one end. This is a simple representation for stack using this array concept, right? So now after performing this pop operation, that pointer is pointing to this that previous positions. Then next one is a stack using this linked list concept. So here push operation in the linked list, you can see this is that linked list representation for the stack concept. So first I am going to perform the push operation. Let me tell you that one by one operation. So you can see initially the top is pointing to this that first node of this that linked list. So when I start to perform the push operation, which means that I'm going to insert the new element into this the previous linked list. So when I start to perform this push operation now, the pointer previously it pointing to this that first element. This pointer is previously pointing to the first element. Now when I'm going to perform the push operation, which means that I'm going to insert the new element into this that already existing linked list at the beginning of the linked list. So now you can the pointer will be changed to this that newly inserted node inside the linked list. So now this newly inserted node will be a beginning of this data linked list. The same way, if you want to perform the operations, pop operation means, so simply I am going to discard the first element from the linked list. So then automatically the pointer it's pointing to this that next element in the linked list. This is the pop operation using the linked list. The basic idea which is beginning in this that array implementation and then linked list implementation for the stack is nothing but, so in this array implementations, first we are going to declare a fixed size of this array which determines this maximum size of the stack, and then keep a variable which always point to the top of the stack. So this is the variable, it's always point to the top of the stack. So contains the array index of the top element. With the help of this that array index of the top element only, we are going to perform this that push operation as well as the pop operation. By knowing the index only, we can able to tell where we are going to perform the index. Sorry, where we are going to perform this that insertion or deletion of these operations. So in the linked list representation or in the linked list implementation, we have to maintain the stack as a linked list in a sequential manner. We are going to maintain. Here pointers variable top pointing at the starting of the linked list. The first element of the linked list is considered as the stack of the top. So now let me tell you this simple representation of the stack as a linked list. You can see yes. So these are the element we are going to consider: 12, 8, 21, 33, 18, and then 40. So initially the top pointer is pointing to this top of the element. So I'm going to represent these elements with the help of this linked list. So the linked list we already discussed. The head is always pointing to this that the beginning of this linked list, and then the last node will be always pointing to this that null pointers. So as it is, so the 40 is pointing to this at beginning of the linked list, followed by this 18 and then 33 and so on. We can able to add this the 21, 8 and then 12 also. So here now the top pointer is pointing to this that starting of the linked list. Let us consider a linked list as shown below in the diagram. So in a given data, we can see that we have a head pointing to this that first node. This head is equal to 200, which is nothing but this address of this the first node. So as we already know the basic definition of this that pointers contain the address of the next variable. So here the address of this node will be stored into the head, and then now the top is pointing to this, that the top pointer is pointing to this 33. Likewise, the address of this 400, the 400, which is nothing but this that address of this, the next is pointing to this node. The address of this node will be stored into the next, as well as this that address of this node will be stored into this node. This is that simple linked list representation for the stack operations. So if you want to perform this the any operation, whether it may be a push or pop at the end of the linked list. So now I want to perform this that any one operation, either the push or pop, but at end of the linked list. We have to traverse all the n number of the nodes or whatever the number of the node will be now. So we have to traverse from the beginning till we have to reach the end of the linked list. We can traverse the whole list from the beginning to this the end of the linked list because we want to perform the insertion or deletion or push or pop operation at the end of the linked list, starting to traverse from the head till this that null. Once we reach the null now, we can able to perform this insertion operation. Fine. Now if you want to insert the node at the end of the linked list as I said, so we are going to traverse from the first node to the second node. till to this last node. We have to traverse from the first node, second node, till to the last node. Now we want to find the end of the list where the node point to this null and the node to be inserted as shown in this figure. So because we already know the end of the link, end of the node in the link is always pointing to this the null. So we started to traverse from this the head and then 33, then 21 and then 8. The 8 is pointing to this that null. So here I am going to once if you have seen this that null pointers and all now. So we believe that we assume that we reach the end of the node. So now I am going to perform this insertion operation at the end of the linked list. So now the new node is pushed, inserted at the end of the linked list. This is a new node which is pushed at the end of the linked list. The second last node, which is nothing but this the 08, now point to this, the location of this last node. Yeah, previously, before inserting this element, this null is pointing to this node. Now, after the insertion of this new node, now this pointing to this the newly inserted node. The newly inserted node at the end of this point to this null. So this always now it is the last node. So it is pointing to this null operation. So this is that simple push operation by using this linked list representations. So here also we are going to perform the inserting the node at the end of the linked list. Fine. Now if you want to perform this pop operation, pushing a node we have seen in this previous one. Now pushing a new node at the beginning of the linked list take place in a constant time. So when I say if you want to insert the element at the beginning of the linked list, so we are going to traverse only one because initially the beginning of the places I am going to insert the element. So it is much faster than the previous method of the insertion because when I want to insert the element at the end of the linked list now, we have to traverse from the beginning to this till the end. But if I want to perform this insertion operation in the beginning of the linked list, we just it's need this the time complexity for inserting the new node at the beginning of the linked list, which is nothing but this order of one because I'm going to traverse the only one node. So let us consider the previous example. They are given in the linked list as follow. I think this is the representation of this given input data. So now I want to insert the new node into this existing linked list, which is nothing but this the 40. I'm going to insert the new node. You can see yes, previously the head is pointing to this the 33. Now you can see yes, this is the new node I am going to insert. So I started to traverse from the head. After that, immediately I am going to insert this 40 node at the beginning of the linked list. Automatically, the pointer will be head pointer will be changed to this newly inserted node. Now the next part of this the newly inserted node will be pointing to this previously previously the node which is act as the first node. This is the simple operation for inserting the node at the beginning of the linked list. So now I'll be clearly tell that explanation. The new node inserted at the beginning where we can just single traversals after spotting the head of the linked list. The value of the head changes from this 200 to 100. Yeah, previously head is pointing to this 200. Now it is changing to this what that 100. So the pointers of the new node stored the address of the next node. Yeah, exactly. The pointers of the new nodes store the address of this next node. This is the final linked list representations after inserting this that new node at the beginning of the linked list. So now we have seen this insertion operation by using the by using the linked list representation in the stack. So next we will be see this another operations like a deletion operation in the programming lectures. Let me stop with this. Fine. Thank you.